Consider this relatively strange formula that says not P implies P and the whole thing implies P. So this formula says something like, if not P implies P, then I can say P. It's hard to translate this into something that is intuitive in English, but it seems an interesting property of our statements, namely that if we have a statement P that when negated gives us the statement itself, then we can really assert that statement. How can we go about deriving this formula? So this formula is an implication, has an antecedent and a consequent. So as usual, to derive an implication, you need to assume the antecedent and derive the consequent. So at the bottom here, I'm going to write not P implies P. This is our antecedent implies P. So this is what we want to derive. And somewhere up here, I will assume the antecedent, not P implies P. This is our antecedent, assumption number 1. And immediately above this line, I'll write P, which is what we want to arrive. So how can I get to P? One thing I can do is that I assume not P up here. This is my assumption number 2. And I use implication elimination. So I have not P implies P and I have not P. This immediately gives me P. Now, there is a problem here, which is I'm not done yet, because I would have this assumption here, not P, which I just kind of made up, and there is no way I could cancel it. So I need some way to cancel it. I would be able to cancel this assumption, not P implies P, because I'm gonna use the rule of implication introduction down here once I have P, and so I can say not P implies P implies P. So I would be able to cancel that assumption using the rule of implication introduction, but I would still be left with this assumption number 2 not cancelled. So I cannot do that. Now there is a way, however, in which I can cancel it. How about I do something like this? I assume not P again. I'm going to assume it the second time. I can assume it as many times as I want. I can assume everything I want, so long as I can cancel it. And by our notational convention, this not P becomes P implies the contradiction. And so remember that the notational convention says that if you have something like not A, that's the same as A implies the contradiction. This is our notational convention. So I've just applied it here. And now I have P implies the contradiction. I can put these two things together and I get the contradiction just by implication elimination. What do I do now? I got the contradiction. Can I cancel my assumption not P? I can if I apply the rule of reductio ad absurdum. So if you remember, the rule of reductio ad absurdum tells you that if you assume a formula of the shape A and you get down to the contradiction, you can say A and cancel that formula. So I'm going to do the same here. I started from not P, I got through a number of steps and I got to the non-contradiction. So I can assert P through my reductio ad absurdum rule and cancel my assumption here, which is precisely what I wanted to do. and these I should index the application of my rule of reductio ad absurdum to the assumption number 2. I can also cancel my assumption here because it's the same and they're all below the same, the p is below both of them. So I can cancel both of them, it's the same assumption. So I keep going, I have p now, I cancel my assumption, and I can also cancel assumption number 1 by applying the rule of implication introduction. So I'm gonna go cancel that. And so now I have at the end of my derivation, not p implies p, the whole thing implies p, which is precisely what I wanted to derive. And therefore I'm done.